Hi friends, my name is Nilesh. In this video, we are going to look at the 15-factor apps, and this is the last part of the 15-factor apps. Earlier, so far in this series, we have looked at 6 different parts or 6 different videos, and we have covered 12 attributes which were originally part of the 12-factor apps. In this video, we are going to talk about the remaining 3 factors which contribute or which form the part of the 15-factor apps. So let's get started with looking at the first attribute, which is called as the API first. What does API first mean? API first means that we define a service contract which allows us to define what is the input parameters for our service and what are the output expected by the consumers of the service. Nowadays, we are in a very hyper-connected world where we are talking about smart devices, smartphones, smartwatches. Everything is becoming smarter day by day. And the way we used to interact with systems is changing almost rapidly. Over the last 10-15 years, mobile penetration has increased so much that we are seeing things like mobile first, where people talk about developing applications for the mobile devices first because people have started moving away from the legacy desktop applications or desktops, and people have migrated over to things like tablets, and they're using that as the main source or main device to interact with various services. So similar to the mobile first, API first is an approach where we define a contract for the API and let consumers know this is how the API is going to look like. There are some advantages of doing this. This allows us to have a very rapid prototyping where we can prototype the API integration with different services. On the left, I've given a small diagram or screenshot which says that the API, it can interact with different things like the games, there is TV consoles, the wearable devices, sensors, mobile devices, typical enterprise application. It can even go on to things like cars. Smart cars, they have capabilities now where they can interact with the online services and the traditional web apps. APIs, they can also interact with other APIs. So API integration is a key. Typical example is like a payment gateway, which can interact with multiple services. So this supports the service ecosystem, and it helps us to grow the business exponentially by creating or encapsulating the business logic behind an API and exposing that API to the various consumers. It could be both internal as well as the external consumers, as well as partners or a partner ecosystem, for example. This also facilitates in automated deployment testing and continuous integration pipelines. So it enhances the overall life cycle of the development, and it shortens the time to market by using the modern day techniques like CI/CD. So typically APIs are well suited for cloud development, and nowadays we hear this term that API is the next thing, like oil is the king, or oil is data is the oil. Similar way, API is the king going forward for all the integrations. People are moving from the legacy integration methods to API integration because they are easier. It enables the consumer and the developers to work in parallel. By exposing the contract, it allows people to test against mock APIs. We can use virtualization of the APIs. There are products and services available which allow the consumers to mock against the expected API, and that way, while the API is getting developed, the consumers, they can start building the application capabilities or capabilities of integrating with that API in parallel, which again helps in the time to market scenarios. So the crux of this API first thing is by using products like Swagger Hub. Earlier there was Swagger Hub, now it is called as Open API Specification. We can build API specification which can be shared, which can be used in automated testing tools, which can be used by other tools to generate code, and it can be used to develop applications faster. Moving on, next attribute or parameter is the telemetry. Telemetry talks about monitoring process performance. Historically, process performance was done using methods like monitoring the CPU or RAM usage because the applications were hosted in one of the servers. and monoliths. They were deployed on one server, and there were very little interactions with other services outside of that particular server. So we could monitor one single server or a set of servers, and we could know the health of the application. When it comes to cloud native applications, these are highly distributed applications, and the legacy methods, they don't really work in terms of monitoring. So this is where things like the metrics and the traces, they come into the picture. If we are in the Java world, there is a product, or there is a open source tool called as Zipkin, which allows us to trace the flow of the transaction or the application. I've again given a small example here, which is related to a checkout functionality. So let's say we are dealing with retail application or online retail store where a person checks out from his cart. Now, behind the scenes, this could be serviced using different services like a cart service, a checkout service. In this diagram, it is talking only about two, but there could be things like the inventory service, there could be things like the delivery service. So all these services, they are deployed independently and they have their own technology stacks. If we want to find out what happened across all of these transactions, then we need a way in which the distributed information or the flow can be traced, and that is where things like distributed tracing comes into the picture. So there are different categories of data when we talk about telemetry. There is the typical application performance monitoring, or APM, what we have been doing historically. There is also domain specific telemetry. So when we talk about domain specific telemetry, it's related to the information regarding the business transaction. Say for example, in this retail example, we can monitor what is the average size of the checkout or basket items, what is the average number of transactions happening in, let's say, 1 hour or 1 day, and we can build dashboards and we can build visualizations to monitor these kind of business specific metrics to say how much business has been done over a period of time. The third thing is also regarding the health and the system logs. Because the cloud native applications are highly dynamic in nature, they can scale up and down based on the different factors. We can also monitor these kind of metrics, which can enable us to notify the end users and also the platform operators in case there is any event happening. So the whole idea about telemetry is to gather information from different sources and to correlate that information in a meaningful manner. Instead of having just the logs or metrics separately, we can use a tool or project like CNCF has a project called Open Telemetry, or OTEL as it is called, which consolidates this information and helps us to present it in a meaningful way. So in summary, telemetry is about gathering information, not just about the technical aspect of the application, but also the functional and how it correlates in end-to-end scenarios. The third thing, or the third attribute that we are going to look today, is authentication and authorization. This was somehow not part of the original 12-factor apps. I'm not sure why it didn't figure in the initial 12 factors, because security is quite important. Security should never be an afterthought. Anytime we deal with any sort of applications, be it on-premise or on cloud, we need to make sure that it is secured at every possible layer. There is this concept called as the defense in depth, which talks about securing the application and data at every layer of the application, starting with the persistence layer or the database or data store layer, then at the application layer where we might have different role-based access, then the infrastructure layer starting with the VM or the compute layer, then the networking, then the perimeter. So in the traditional way, before cloud became commonplace, we would secure the perimeter to the office buildings, and it was assumed that if the person had access to the office, then with minimum level of security, we could secure the data and the applications. That is no longer the case now, since we are deploying applications to cloud and we don't have the same level of access as we had before. As we move away from different cloud services like infrastructure as a service, platform as a service, software as a service, the kind of access that we have to the resources it goes down with every step. So we need to make sure that we adhere to the best practices in terms of security. So we use things like OpenID Connect or OAuth 2. There is single sign-on, the servers, there are standards available like SAML. When it comes to the programming languages, there are language-specific libraries for authentication and authorization. So on the right hand side, here I have a small diagram showing defense in depth with Azure services. Although I'm depicting Azure here, this can be used in other cloud providers using similar services provided by your cloud provider. So we are looking at identity and access management, where there are things like Azure Active Directory, there is multi-factor authentication, role-based access, the identity protection for Azure Active Directory. Application and data protection is with the encryption. There is the key management using Azure Key Vault. Confidential computing, which allows us to perform operations on the VMs with specific confidential computing capabilities. At the network layer, we have VNet, VPN, network security groups, things like application gateway, the web application firewall, Azure firewall, DDoS protection, express route, and so on and so forth. I won't go into each and every service mentioned here. The crux of this is we should secure the application at every layer and every stage. We just don't believe that a person has access means he is the right one to have access to the application and services. Here is slightly different view which talks from the client security, then the server security, network security, and data protection. So when we are dealing with data, again, there are things related to securing data on the disk using things like encryption, disk encryption, using keys which are managed by the cloud provider, as well as bring your own keys. There is also things like transparent disk encryption, which is supported by Azure SQL, for example, or Azure Synapse. There is another layer or another way of encrypting the data as well, like Azure Synapse. It provides a feature called the dynamic data masking, where even if the person has access to the data, we can define at a row and a column level what kind of access a particular person has to that information. So these are different ways in which we can secure data as well as the applications. And when it comes to different kinds of services and applications, we should secure them in different ways. So APIs should be secured using things like OpenID or OAuth and role-based security access. When it comes to the websites, we should never have a plain HTTP site. We should use HTTPS to secure the websites with SSL certificates. When it comes to the web applications, we should use multi-factor authentication so that the person can authenticate himself, not just by using, let's say, a username and password, but by also augmenting that information with secondary information like a PIN, which is validated like a one-time OTP password, or using some secure device. And then at the database level, as I said, we need to secure the data access at the disk level when the data is in motion on the wire, as well as when the data is in use. So authentication and authorization is all about securing the application and the data at all the layers using this different mechanisms which I talked about. So with that, we come to the end of this video, and I would like to share some references like I did in the earlier videos, starting with the Beyond 12-Factor app by Kevin Hoffman, which is a report available on O'Reilly. There are a couple of GitHub repositories, one by Christopher M. Judd and Vikas Gupta for 15-factor applications. And there is also a Medium post by Vikas Gupta. You will find the links to all these references in the description of the video. When it comes to cloud native Java applications, Grace Jensen from IBM, she has a post, and there is also a YouTube video where she talks about all these 15 factors in the context of Java applications. So a quick summary of what we did so far in these 7 different videos related to the 15-factor apps. We started off with the first 2 factors, code base and dependencies. Code base talks about having one single code base tracked in the version control, which can be used to do multiple deployments. Dependencies talks about explicitly specifying or declaring the dependencies that the application has and also isolating those dependencies. Then we talked about the config and the backing services. Config is about storing the environment configuration. It's about externalizing the configuration from the application code. Backing services is about treating backing services as attached resources. So typical examples of backing services is the databases like relational databases or NoSQL databases, document databases. It could be messaging services like Kafka or RabbitMQ. It could be caching services like Redis. Anything that is external to the application and which can be swapped across environments, we can treat that as a backing service. Next, we talked about build, release and run cycles, or design, build, release and run, strictly separating the build and the run stages. And then about the processes, which talks about executing the application as one or more stateless processes, which allows us to scale the application. In the fourth part, we talked about port binding, which is about exposing services via ports, and concurrency, where we talk about the scaling of application via the process model. The next part was about disposability and dev prod parity. Disposability talks about maximizing the robustness of the application using fast startup and graceful shutdown. Dev prod parity is about having a similar kind of environment as much as possible between all different environments, not just about dev and prod. We might have multiple environments. The idea is to have the settings across all environments as close as possible to the production. The last episode we talked about, or the sixth episode, was about logs and admin processes. Logs is about treating logs as event streams, and any one-off task which we want to do, like an admin task or a management task, we should run them as a similar to the normal process itself. So with that, we come to the end of these 15 factors applications or 15 factor apps series. I hope you found this useful, and hopefully you gained some knowledge about how to build highly scalable applications, highly resilient applications using these 15 factors. So until next time, code with passion and strive for excellence. Thank you for watching this video.